So now in this video we're going to cover series capacitors again. So we covered this one in the last video where things are working out well. So I used higher value capacitors and a higher voltage. But the main premise was the same. We had two equal value series capacitors. When you have capacitors in series, you want them to be equal value. What that does for us, first off, it gives us half of the supply voltage if there's two of them, and it gives us a third if there's three of them, and so on. The other thing is that the voltage gets split up, the supply voltage. So we got 3 volts. So this is a low voltage. That's because we're purposely going to do things that may damage it. But this is a low voltage, but let's just say these two capacitors I have for some reason can only be charged to 1.5 volts. So I can use them with 3 volts in this case. So in any case, this is when things work out. We covered that out in the last video, and so we're going to move on. This video, we're going to look at a problem. So there's a number of reasons why one of the capacitors may discharge. And the thing is that the other capacitor gets that voltage. So the most obvious is if we short circuit it. So now we have a path, 3 volts across that capacitor, and then that's the same node right there. If the capacitor has a charge, it will discharge and have 0 volts. So that is one of the biggest risks. Now, even if you don't short circuit it, maybe something with some resistance will drain it over time, like the multimeter or whatnot. But something else may drain it. But there's also some leakage inside where current trickles through the plates. So if this one's leaking a little bit more current than that one, then this one's also going to be charging. And it'll trickle through. And so that will gain a voltage. So depending on how bad the leakage is, if it's really bad, you will end up with the 3 volts up here and the 0 volts down there, no matter what you do. So, in any case, even if we short it and remove the short, this capacitor, at least for a little while, is going to stay at 0 volts. So again, there may be a little leakage there that helps charge it up. Well, that one goes down over time, but you don't know for sure. It's best to avoid having them at different voltages to begin with. You never know for sure. So we have this state here. Still not horribly bad yet. The problem is when we go to discharge them, and when I turn off the power supply, it automatically discharges them. And if one is at 3 volts, like here, then it charges the one that is at 0 volts. So this is more positive up there. That makes that plate more positive as that gets less positive. And then this plate is negative there. That makes that plate more negative as that plate gets less negative. And so ultimately, that plate is negative, but you can see there's a plus sign there. This is polarized. That side is not meant to be negative. And then positive there. Again, polarized. That side is not meant to be positive. Now there are non-polarized capacitors. Those can be charged in either direction, no problem. So one of these would be fine here, but these non-polarized capacitors are lower value capacitors, and somewhere around about 1 microfarad you start running out of these being available, the non-polarized, and above 1 microfarad you're getting to where you're pretty much guaranteed to have to use a polarized capacitor. So that's why you can't just substitute the polarized for non-polarized. But in any case, especially at higher voltages, I don't think 1.5 volts will damage it, but it might. But in any case, it's only a 2.2 microfarad capacitor. I have a bunch of them. So if I do damage it, oh well, I'll throw it away. But I think we'll still be safe at that voltage, but especially at higher voltages, it's very bad to reverse bias it. So let's look at this on the board. And here we are on the board. So right now the output is on. I'm going to hit the power button so the output goes off. And I'm going to show you why. I have a little problem with this power supply. I noticed it when I bought it, but I really like this supply for what it is. But when you turn the output, the power, to the rail off, it actually gives you a negative voltage of about 0.6 volts right there. And so hopefully these split these up easily. Okay, that one has a little bit more of the negative charge, and so this one's going to have a little less right there. So that's just something to be aware of with this power supply if you don't think your components can handle it, but you also think this is the best supply for what you can get. Just get the components off before you turn the output off. So in any case, now the output's on. We are providing voltage to the power supply right there. And it's hard to find a good portable power supply like this. And so something like that, it's not going to stop me from buying it. So in any case, there we go. We got 3 volts across the two of them. That one, I think, might have slightly less than half. Yep, there we go. And this one's slightly more than half. So you can see right now, the reason why the voltage is dropping is because the resistance of this meter, even though it's very high, these are very low value capacitors. And so it doesn't take a lot of current going through the meter to lower their voltages. So again, we could do this long enough for it to maybe discharge completely, but we're going to grab a jumper and discharge this one completely. So again, they're low value and they're not to a very high voltage, so we can just short it right there. So of course, with the jumper there, that's connecting there to there is making the exact same connection. We're going to have 0 volts. But when we yank the jumper, we should still, at least for a while, have 0 volts right there. So that is close enough to 0 now, where I am going to cut the power. So right now the output is on, and again we're going to get a negative voltage to the rail, so it's actually going to make it slightly worse. But in any case, we'll turn the power off. First, let's look at this one. This should still be in the positive region right there. Yep, doing plenty fine. We come over to this one, and there you can see the negative voltage, about negative 1.5 I mean. And again, the multimeter is balancing those charges, so they're getting a little bit better. But in any case, that's the main danger, especially when you get to higher voltages. Hopefully these voltages aren't bad enough to do any damage. So I'll turn the power on. And I know I'm not an expert on polarized capacitors, but I know they depend on the being properly charged to hold that polarization. And so we're going to apply the voltage there. So they should already be in the positive region, but now I'm going to put both of them, especially this one, to the positive rail. Positive side of the positive rail, negative side of the negative rail, I should say. And so they should be correctly on there, and I'm going to raise the voltage up there. So I think slowly raising the voltage helps get that chemistry back in line. But again, I'm not an expert, and I don't know if you can really do much to repair them if you damage them to begin with. But in any case, I know having them properly charged is good. So that's it for this video. Thanks for watching. Make sure you check out one of the other videos I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most. I have links down in the description. But just watching videos helps out a ton. Thanks to everybody that does that. I'll see you in the next video.